it's using even emojis in coding. Emojis, people love emojis. That's why it's all over AI code generators. Ah, right. So it's okay. It's kind of working. It's looking inwards as well. But okay, it's actually yeah. It's not quite able to look at the nose, but okay. Let's see. Yeah, yeah. So the good thing about not the good thing about Claude, because so when you have code in just one HTML, yeah, we copy it onto a server. Yeah, there's all sorts of problems with this code as well. The fingers are getting extended like that, so we have to fix it. The flexing stopped working, so we're testing those. That's EMG simulation. The chatbot is slow and not accurate. Okay, now we have the cat still jumping to infinity and beyond. It's not. Yeah. So it's following. Wait, where is our? We should have a. We should have a transcriber. We're using our own. Yeah, this real-time speech visualizer. No, I didn't swear. Just pop it in here. Hey, okay, so the cat eyes are working okay. It's much better, but it's working really well when the mouse is around the cat, like outside the boundaries of the cat SVG. But when it's on top of the cat, when it's on the body, it's working fine. But when it's on the head, when it's on the nose, yeah, we could fix that, because currently it's not actually looking at the nose. Yeah, so it seemed to only work when the mouse cursor is just outside the head. Yeah, having some trouble when the mouse cursor is on the nose, for example. Yeah, I'll just try one or two prompts and out, because most of the time we spend on fixing the code. It's sometimes deciding to generate another script, another artifact, or whatever it's called, but now it's actually fixing existing code or rewriting it. I'm not sure if it's fixing it or not. And we also have the webcam thing while it's generating a webcam. Let's see if we put it in a pixelate start webcam, allow. Yeah, so we have the webcam working okay. Yeah, it's using too much resources. I can hear my CPU, GPU going. Actually, not with the pixelation thing, so it's actually fine now. I like the edge detection better, but if we stop the camera for example and put it on edge threshold, if we make the threshold actually higher, let's say 90% or something. This one's still using quite a lot of resources. I don't know why. To fix it. Yeah, now it's lagging. Not great. The cat is not lagging. It's just a simple SVG, much better than using the camera, isn't it? Yeah, now the fans are off. It's not running. Anyway, we'll just keep it. We'll just keep testing it. And we have the code. This was for the cat catapult. Catapult. That's what it's called. Catapult. Do you like the name? So currently have 300 lines of code. Okay, 322. Okay, now it's actually working. It did fix it. Yeah, Claude is pretty good. Coding, can't do anything else. Doesn't have speech. I mean, it can understand on the phone. You can actually talk to it, but we kind of have our own text to speech that's working fine. So the cat is working okay. Yeah, this one actually quite like. We need an explanation for what's what. get the ChatGPT to do the explanation. We were discussing these web applications in the images that I provided. Can you actually, we need to write an explanation of like how to use, give some background on it. Or we might actually improve it first. No, we will improve it first. Can you make suggestions? We discussed it before. Does it make sense to have additional channel? I don't think so. Maybe just have the one channel, leave the one channel as is. Stop recording, start recording is okay. Clear button is okay. Based on noise, flex intensity works fine. We want to add more buttons. So what would be additional things that you would recommend in addition to a flex button? What other muscle EMG actions a hand can make? So I'm thinking grab, throw, I don't know what else. What makes sense? Considering we only have one sensor, what will make sense with that? Just talk to the bot like this.
For a single sensor setup, you could add buttons for simple muscle actions that are distinguishable via EMG data. In addition to flex, consider actions like grip, extend, or relax. These could simulate grasping, stretching fingers, or returning to a resting state. Since one channel limits complexity, you might also consider introducing a toggle or cycle mode button that switches between predefined gestures or actions, e.g. from flex to grip. This would maximize functionality without requiring additional hardware. You could even explore dynamic range adjustment to let users fine-tune how sensitive the sensor is to muscle activity for each action, tailoring it to different muscle groups or individual use cases.
I don't get it. Okay, so we have a single flex button, which is working really well. Can you list other muscle actions? Okay, we have grip, so we have flex, grip, extend, pinch, wave, tap. But those could be mimicked by the flex. Okay, now I'm thinking instead of a flex button, we could have a more complicated controller. What other controller you would recommend instead of a button to mimic muscle? So you'll have intensity can be controlled by, the other thing, we could eventually have a camera, detecting different muscles. Then you place different sensors, EMG sensors, onto your own body or just the arm, and we could mimic, we could do something more complicated, like essentially having a camera and control a hand and show you which electrode, EMG electrode, gets activated. But for now, we're just trying to keep it simple. But I'm still thinking replacing the button with a different type of controller that actually more representative of muscle-like activity. What do you think? Some sort of switch, some sort of spring. Eventually write instructions for Claude.
Replacing the flex button with a more dynamic controller could make the interaction feel closer to real muscle behavior. A slider or dial would let users control flex intensity in real time, mimicking how muscles contract gradually instead of being binary. For example, 1. Spring slider, a slider that resets when released, simulating muscle relaxation after contraction. 2. Circular dial, a rotary control representing continuous motion like gripping harder or extending further. 3. Joystick, a virtual joystick to simulate directional muscle movements, e.g. flex versus extend. 4. Force gauge bar, a bar that fills or drains based on the input, simulating tension or fatigue over time. These would make it more representative of how muscles behave dynamically and allow finer control. For now, sticking to a slider might be simplest and most intuitive. What do you think?
And they all sound really good. I like this application actually as is. I like the simplicity of it, so we might actually start a new web application like this. So based on what we discussed, if we were to start a new web app, just using a JavaScript and HTML, only like visualization libraries are fine, for the charts, but everything else vanilla. Can you write instructions for another robot, another developer to generate code from scratch?
Here's a clear set of instructions for your other developer robot to build the new web app from scratch, sticking to JavaScript, HTML, and minimal visualization libraries. 1. Set up basic HTML structure. Create an index.html file with a simple layout using CSS for styling. The file should include a header with the app's name, a main section containing the EMG controller, like a slider or dial, a graph, and real-time value displays, e.g. peak amplitude, RMS value. Footer with basic info or links. 2. JavaScript setup. Add a script.js file for functionality. Use JavaScript to dynamically update the graph based on...
Okay, didn't get it. So we want the simulated EMG waveform, and yeah, so we wanna see some sort of controller to know which one you chose that represents the motion of a muscle. Potentially measuring EMG without the hardware, just using what we've got, which is a touchscreen, which you can, to move on a touchscreen, you need your muscle. We are mimicking the mouse motion, so indirectly recording EMG. While it's generating, go check out the website. Actually, we can measure EMG on this cat. And pretty much any biomedical recording, if you have motion in it, it's indirectly measuring EMG, isn't it?
All right, here's the pitch. You're turning mouse drags and touchscreen swipes into fake EMG, basically tricking your computer into thinking it's a muscle lab. Skip the electrodes. You're using motion as a proxy. It's clever, cheap, and a bit like asking a cat to babysit. It works, but it's not exactly the real deal.
Oh, yeah, that's what we've got. We've got cameras, so we can do EMG on the camera, or we can use the touch screen or mouse to mimic EMG. That's right. Or shall we just give it to Claudette? Well, maybe we'll do both, because Claudette will take some time to generate code.
The idea of simulating EMG waveforms using just the user's interactions, like mouse movements or touch gestures, is brilliant and creates a fascinating way to mimic EMG activity without actual hardware. Here's how we can structure this application and make it engaging. Controllers to mimic muscle activity. 1. Single controller, recommended for simplicity. A spring slider is a great start. Users drag it up or down or left to right, and when released, it springs back to the baseline, simulating muscle relaxation after contraction. The slider position directly maps to waveform intensity, creating a dynamic, muscle-like interaction. 2. Multiple controllers for more advanced interaction. A joystick-style control could let users simulate more complex motions, e.g. flex by pushing up, grip by pushing down, extend by pushing left, pinch by pushing right. A dial or knob can control the force or intensity of the contraction. Users rotate the knob, and the EMG waveform adjusts in amplitude. Combining these would allow users to experience more nuanced and varied muscle behaviors. Simulated EMG waveforms. Using a controller, we can generate synthetic waveforms. Base signal, a clean sine wave that oscillates at a frequency mimicking typical muscle contractions, e.g. 20-150 Hz for EMG. Intensity modulation. Controller inputs modify the amplitude of the waveform, representing muscle force. For example, higher slider positions, larger amplitudes. Faster joystick motions, frequency bursts to mimic fast twitch activity. Baseline noise. Add some randomized noise to make the waveform look authentic, simulating the slight variability in actual EMG recordings. Visualization layout. Keep everything visible within one viewport. 1. Top section. The controllers sit at the top for immediate interaction. They're prominent and intuitive, whether it's a slider, joystick, or dial. 2. Middle section. A real-time waveform display occupies the central area, showing the synthetic EMG signal. Use a lightweight visualization library like Chart.js for this. 3. Bottom section. Display calculated metrics dynamically updated with the waveform. Peak amplitude indicates the strength of the contraction. Mean value shows the...
Okay. A couple of things. So yes, we could test it out. Yeah, this is the older model. What would you call this web application? It's thinking forever as well.
EMG without the mess.
MyoMo. MyoMo is actually pretty good.